All right. So I've got this thing, and so, but I know that u is x minus 3. So all I do is replace u with x minus 3. So it's x minus 3 minus 3 and x minus 3 plus 1. See, I just replaced the u. All right, and I can make it look better, you know, -3 and -3, that's x minus 6. And -3 plus 1 is -2, right? Now I'm done. Okay.
So x minus 2 and x minus 6 is your answer?
That would be my answer, right? Okay. That's factored. Eventually, we'll get to solving these, but I don't think we do that until after we do it, I think next week, I don't know. Sometime soon we'll do that. All right, so let's go see what's coming up here. She's got, I need to do a different example with you guys too. Okay. She got down, but she needs. Sorry. Let's try this. Let's try that. There we go. Well, almost. It's being a little picky. Come on, register. Sorry, had a little problem there with that. All right, let me get rid of this guy. Come on. What's going on? There we go. Thank you. And some weird stuff. Let's do it this way. All right, so what I see, this is kind of the same type of problem we had. It's just a little harder because it's got a 2 out front. So you're going to let u be, in this case, x minus 1 to get rid of the parentheses. So I get 2u squared plus 5u, whoops, plus 3, right? All right, which is something that's so much nicer, I can factor that. All right, so we multiply the first and last. We're going to do kill a common factor. So 2 times 3 is 6. So you need factors of 6 that add to +5. So what are they? Yeah, 2 and 3. All right, so remember with the Barry's method, you copy the lead term to the front. So I copied the 2, then I write my factors down. Okay, so I copied this, and I kill the common factors. So if I look at the first set, I can take a 2 out of there, right? Destroy it. All right, so I get u plus 1. And on the second set, nothing I can do with it, right? So I leave it alone. All right, so my last step is to replace the u, right? U is x minus 1. So I'm going to go back and replace that. All right, so if u is x minus 1, I get x minus 1 plus 1. Now, 2u would be 2 times x minus 1. You better put that in parentheses. Plus 3. All right, so the minus 1 plus 1 cancel, so that's just an x there. Right, this other term, distribute the 2. It's 2x minus 2 plus 3. And combine the numbers. Minus 2 plus 3 would be plus 1, right? And there I am. Okay. So if it has 3 terms in it and you're working in a calculus class, most often than not, you're gonna be factoring it. All right. So that's just a clue for me when I see 3 terms. Oh, it's probably some kind of quadratic. All right. You guys okay with this so far? I'm about to put fractions in the mix. All right, so it's got 3 terms, so I'm thinking, well, it looks like something, right? Something. So I look at this, and whatever is here, this is like my x term, right? So I'm gonna let u be x to the 1/4. All right, that's what it tells me, whatever that power is. So if I let u be x to the 1/4, I want you to think for a minute. Well, what would u squared be? U squared would be x to the 1/4 squared, right? And so remember your exponent rules. You're going to take a test on that tomorrow. A power to a power, you multiply, right? So 2 times 1/4, if you want, that's like 2/1. So you get x to the 2/4, or you get x to the 1/2 if you reduce it, all right? And again, you can plug that in the calculator if you weren't sure, right? So, all right, so you see that that's u squared is x to the 1/2. Oh, look, there it is right there, right? There's my u squared, okay? All right, so now I know I can replace it. This is u squared minus 9u plus 20. All right, now I have something I can factor. All right, I need factors of 20 that add to -9. What would those be? If you have troubles with the factors, remember you can do the number divided by x in the calculator. All right, anybody got the factors? 5 and 4. Good, 5 and 4. And to get that -9, I'm going to make both of them negative, right? All right, so what I have is u minus 5 times u minus 4. Okay. My last step is to replace the u. Well, u is x to the 1/4. All right, so I'm going to replace it. So it's x to the 1/4 minus 5, x to the 1/4 minus 4. Okay. It's all right. Read this stuff. Let's see if they'll let me do it now. Nope. Let's try it this way. Nope. I don't know why it's doing that. It won't let me pick a whole selection and erase it. But it sounds kind of looks like the internet's a little slow. Would be my thinking. I have another job where I work on the internet. Today it was in my house. It was very, very slow. All right. So again, you know, like it's got 3 terms here. This next example, I'm thinking, well, what should u be? U should be whatever that middle term is. So u should be x to the -1. All right. So this should be my u. U equals x to the -1. Because think about it. If I square u, again, you multiply them, so it's x to the -2, right? So the first term is u squared, okay? So I get u squared plus 5u plus 6, right? And there we go, okay? And we can factor that. It's the same thing we just did a minute ago, right? So it's factors of 6 that add to 5 would be 2 and 3. So this is u plus 2 times u plus 3. But u is not u is x to the -1. So we're going to go back, put this in here. So x to the -1 plus 2, x to the -1 plus 3. Eventually, you'll be interested in writing that as 1 over x and then solving it, setting it to 0. We're not doing that yet, so we're not as interested right now. Okay. The point is, when you have 3 terms, it looks like a quadratic most of the time, especially in calculus class. All right. We good so far? Okay, before I leave you, I want to show you some more advanced type of factoring that you will be seeing in calculus that she didn't cover here. All right, just a couple more examples just to make sure you've seen them. So a lot of times what happens is you go to take something called a derivative and you have to set it to 0, and the derivative can look just straight scary. All right, and I want you to understand that some of this stuff is not all that scary. So I'm going to make up a problem. Okay, we'll kind of see what happens. All right. So something like this. I want to factor it. All right. And whenever you factor, you want to take out common factors, all right? But when they share factors of x, when the powers are negative, take out the most negative factor of x you can, all right? So when the powers are negative, you're going to take out most negative power. If they all have a power of x in them. So when I look at this, I go, okay, the most negative power I have is x minus 4 to the negative 10th, right? So that's the one I want to take out. If you like, you can well, I don't really want to let you be x minus 4. I'm just going to leave it that way. Okay, so x minus 4 to the negative 10th is the most negative. So I'm going to factor it out. So when I factor it out, it means I have to divide by it. And let's watch what happens when I divide by it. Okay, so you see that these guys right here, they have the same base, right? So we just subtract the exponents when we divide them. So I need to do -9 minus -10. 2. I got the 2 just comes down a line for a ride. So it's x minus 4. So I'm going to do the -9 minus a -10. So you see how that comes out to be 1? So it's 1. Okay. And then this other guy is even easier because those just straight up cancel because they're exactly the same, right? So you have x. So what I'm left with is x minus 4 to the -10th. Now on the inside, the 2 distributes. So it's 2x minus 8 plus x. And I can combine the x's on that last one. Let's see, 2x plus x would be 3x minus 8. Now I've got a factor, okay? So when you have negative exponents, negative powers of x that they all share, you want to take out the most negative power that you can. All right, and I'll do another one just to drive it home because that happens frequently, right, in calculus. All right, let me find some space somewhere for y'all. Here, we'll do it here, and then I'll just, okay. So I'm going to make up another problem. Let's do, hold on, I got to do a little bit of fraction work in my head. I need paper. Well, here we go. I gotta make sure I got it right. I'll just. There we go. And then if I do this, then I have to multiply by. Sure, we'll do it this way. Okay, let me show you an example of what I'm trying to get at here. That'll work, won't it? 12, yeah, okay. So I'm gonna make up a problem. This idea of taking out powers of x, it holds with fractions too. Okay, so you see that there's 3 terms here, so it's got to be some kind of quadratic, okay? The question is, how do I factor this? This is this deal, you see they all have a power of x in it, right? So there's some power of x I want to take out. So the rule is take out the most negative power of x you can find. So the most negative power of x I have is x to the -1/2. So I'm going to take that out, okay? So if I take out x to the -1/2, I divide each of these by x to the -1/2. Okay, so I pull it out, and then I'm left with, see, so now I got to do 3/2 on the top. I'm just going to write this over here. I have x to the 3/2. I'm going to subtract a -1/2. Right? So that makes it a +1/2. So 3/2 plus 1/2 is 4/2. You know, you do your calculator, you should get 2, right? Okay, there we go. So it's x squared. Oh, I got 2 there. Sorry, 2 has to go with it. And then I have x to the 1/2 minus a -1/2. So the 2 negatives become a positive, right? So it's 1/2. What it becomes, it's just x, right? Yeah. And these guys straight up cancel, so it's plus 6. So what I have now is something I can factor, okay? So when you have negative exponents that they all share, take out the most negative power, all right? So now I can rewrite this. I'm going to go up here. All right, so I need factors of 12. Did I do that? Did I say that? How about we change this to a negative 6, okay? Just to make it work out. All right, we'll make this a negative 6. So I need factors of negative 6 times 2 is negative 12 that add to negative 1. So that's going to be what? What are they? Okay, I saw somebody mouth it. Negative 4 and 3, right? Those add to negative 1. So we can factor this just like normal. We're going to copy the lead term. So you're going to copy the 2 to the fronts. Write down your factors. And then you're going to kill the common factors, all right? The x to the negative 1/2 just comes along for the ride. I can take a 2 out of here, so that becomes x minus 2. And the other guy becomes 2x plus 3, okay? He stays the same. Is that all right? Okay, so this is your more advanced type of factoring. So the things I can tell you, the hints I can give you for 1325, when you have negative powers of x, take out the most negative power that you can, all right? If you don't have all powers of x, like let's say, where was that? Like up here, let u be this thing right here. Let u be x to the negative 1, that'll probably work, all right? So, and those are your, and then this thing, obviously it's x minus 1, so. Anyway, so those are things you're going to run into in 1325. Okay, I taught calculus for 10 years. Okay, I know. All right, so be aware of that when you go, oh wait, there was something I needed to do. How did I do that? Well, I might go back and look at my 324 notes. Okay, all right. So we're going to go back and we're going to talk about augmented matrices. We're going to talk about the 1324 stuff. Just to make this clear, because I got another email today. 1324 is a separate class from 324. You get a grade here, you get a grade in her class. None of her grades go to my grades, none of my grades go to her grades, okay? They are separate, okay? My homework is only based on my stuff, the algebra. Her homework is based on 1324, all right? My test is only based on the algebra, the second part of the packet, okay? That will never change, all right? Whatever they say is what they say, and what I say is what I say, okay? We got it? Okay. So please don't, don't think, oh, my 1324, your 1324 grade, I don't even know what it is, I got no idea. Okay, it has no import to me. Okay, all I'm worried about is the algebra. Okay, okay, so let's go up and find the 1324 stuff. We're gonna find 4.2. So 4.2 matrices. We're talking about matrices. 4. 1. Let's see, 4.1. Okay, so we did that online, and then we have 4.2. Where are you? There we go. Okay, so we're going to talk about how to set up matrices for simplex Tableau. All right. The thing with simplex Tableau, in order to use it, you have to have the matrices set up correctly. So that's what we're doing today. So this is on page 40 on your packet. Okay. So an augmented matrix, basically it's augmented because it's got each row of an equation plus the solutions on the end. You tack the solutions on. And each of the coefficients is a single variable. So if you look at the system of equations, you put it in an augmented matrix right here. You have to put the variables in order, X, Y, Z, right? And you have to put the answers at the end. It must be written like that for you to write an augmented matrix. Now, and see, I should just wrote the coefficients. When there's nothing there, it's a coefficient of 1, right? These are all 1s. So 1, -2, 3, and then they write the answer with a little line there, okay? And then the other one's 1, 1, 1, 4, and the next row is -3, 22, -2, -10. All right, so this is what we call the augmented matrix, right? This is kind of like what you're going to put into simplex, except that the objective goes in the bottom row, right? You make those guys negative. Okay. Okay, so, and she's just talking. The vertical line is just distinguishes between the equation and the equal sign. Honestly, do you need it? Well, they want it, but I mean, it doesn't do anything. It's just there, right? It just tells you, oh, those were the equals. All right. Oh, the vertical line is not always included. Okay. All right. So if I want to make an augmented matrix from that system, I'm going to check and make sure that all the X, Y's, and Z's are lined up and all the numbers are lined up, which they are, right? Okay. So all I have to do is make a matrix. It's real simple. Row 1, write the elements. X is 3, Y is 1, Z is -2. The answer is 2. X is 1, Y is -2, Z is 1, the answer is 3. -1, -1, 3, and 6. All right, and they put that line there if you wanted. Okay, so that's the augmented matrix. All right, so that's something like that I would enter into simplex. All right. Yeah, if a variable is missing completely, put a 0 in its place. All right, so if I had something like X plus Z equals 6, I would write this, Y is missing, right? So I put a 0, so I'd write this as 1, 0, 1, 6, right in that row. All right, so if something's missing, make sure you put a 0 in there. All right, so we're gonna practice rewriting them. So rewriting them in standard form, this is how you wanna write things, right? You need X, Y, and Z on one side and the number on the other. So whenever you move something over to another side of an equation, you change its sign. That's, I think, the easiest way to do this. So when I look at this, I can move them to the left, I can move them to the right, it doesn't matter. I'm just going to move, right? All right. So I see a -x. So to move it over, I'm going to add x to both sides. You see that I'm just changing the sign. So to move it, just change the signs, right? So the -x becomes a +x. All right, and if I want to move the Z to the left, I'm going to subtract it. So positive becomes a negative. Now, the only thing I got to do, I got to get rid of the -4. So I'm going to move that to the right. So I'm going to add 4. All right, so my total net equation is X plus 2Y minus 3Z equals 4. Now, honestly, I just move them back and forth. I know if I change a sign, a negative becomes positive, a positive becomes negative. All right, so my coefficients would be 1, 2, -3, and 4. Okay, just put them in alphabetical order. So I'm going to do this next one the quick way. I'm just going to move stuff over. So the -8x, if I move it to the right, it becomes a +8x. Right? I've got a -3y. 5z is going to come over, so it's becoming a -5z. I just change the sign whenever I move inside. And then the 7 has to go on from the left to the right. So the 7 is going to become a -7. See, I just switch them, change the signs. All right. So the x coefficient is 8, y is -3, z is -5, and the answer is -7. Okay, just seeing what she's doing. All right, so I'm going to keep, so the -5x goes first, right? I'm going to move the y over to the left-hand side. So the positive y becomes a -y. Okay, so I'll move that over. And then I have a +9z on the left side. That's good. And what's left, don't forget the negative, right? It's equal to -8, right? Don't drop signs. All right, so there's my coefficients, -5, -1, 9, and -8. All right. The big thing with the simplex tableau is just making sure you plug the matrix in right, and you get the right equations. That's because other than that, you're letting the program do all the work for you. It doesn't have to make any sense as to how it works. We take by faith that it does work, right? That's kind of how you do this. I actually went and looked it up, like why it works. And I go, okay, we take that on faith. Because it was like Calc 3 and above, like how they saw those things. And I went, oh, no. There's no way that they can give you any insight to why it works. I don't know if she told you that, but just, okay, it works, right? Okay, and we're happy. All right, so when I look at this, I have 2x. Now, I don't have any y, so what I like to do is just put 0y, so I remember that there's no y. All right, and then -z equals 6. So there really wasn't much to do here other than I'm going to put a placeholder for that y that's missing. All right, so the coefficients of the matrix would be 2, 0, -1, and 6. Is that okay? Yeah, we should talk about that too. All right, so here's the deal. Do I want to move everything to the left or the right with this equation? You know, this is kind of either way will work, right? So these equations aren't necessarily unique, I guess is what I'm trying to tell you guys. Okay, and that's okay, all right? So if I move the x to the left, let's just do it that way, it becomes a -x. And then I'll put -7y plus 4z. If I move the x, there's nothing left on the answer, so it becomes a 0, right? So the coefficients for the matrix would be -1, -7, 4, and 0, all right? Now, what I'm trying to get you, what if I wanted to move everything to the right? I could do that. Okay, I'm just going to get a slightly different equation, all right, but it'll still work. All right, so if I'll move it to the right. So let's say I did 4z minus 7y equals x. So let's say I want to move the y over. So I get x plus 7y equals 4z. Now I move the 4z over and it becomes negative. And then it equals 0 because there's nothing left. All right. So you see that my coefficients are actually the -1, 7, -4, 0. The negative of what I started with. So I want you to understand it doesn't matter which way you move them. Okay. So you could get a different equation and you could be okay. All right. In fact, you could multiply them all by 2 and you still be okay. All right. Is that all right? All right. So, all right. So now we're gonna practice rewriting them and giving the augmented matrix just to make sure we can. All right. So like number 1, I look at this. I would rewrite this 4x plus 6y minus 3z equals 30. All right. So I just have to put them in alphabetical order. Let's see what will come first. Now don't forget with the 2x there's a negative there, right? So it's -2x. Oh, now I'm going to move the 5y over. So let's become a -5y. Then I've got plus 7z equals. Now the 20 is on the right. I need it to be on the left, so I'm going to make it negative. All right. So anytime I change sides, I change the sign. All right. All right. Okay. Last one. I got -x. I have a -x. I have a plus y. 9z's got to go over, so it becomes -9z. And the -40 is going to go over, so it becomes a +40. Right? And so now my equations are all lined up correctly, and I can write my matrix. The matrix is just all the coefficients. All right, there's my matrix. Okay, and you can put that line in there if you want to. Yeah. All right, you okay with that? Oh yeah, we got to do slide variables. Okay. All right, so let me kind of go this way. All right, so let's line them up. All right, so let's see. I want the 2x to get moved over to the left, so it's going to become a -2x. The -5y needs to get moved over, so it's a +5y. 8z stays where it is. -7 gets moved over, so it becomes positive. Is that all right? All right, next one. I got a -x, so -x plus 2y. Z is going to get moved over, so z becomes a -z. And the -4 gets moved over, so it becomes a +4. Okay. All right, there is no x term. All right, when there is no x term, it's a 0x, right? So it's 0x plus 6y. Now the 4z's got to get moved over, so I'm going to minus 4z. And what's left is nothing. All right? So there, and I would make a matrix out of that. Okay? Always do it in alphabetical order. If a variable is missing, put a 0 there. Okay? All right. All right. All right, let's see. So this one, I would just rewrite negative 3x. There's no y, so I'd write it as 0y. Plus 8z equals 2. That was pretty easy. All right, x comes first, so it's negative x. Plus y, there's no z, so it's plus 0z equals 1. Next one, no x's. Right, we just write them down. Okay, so then we can make a matrix. Okay. All right, lots of examples over that. All right, main thing is when you switch between sides, you change the signs. All right, I'm going to ask you something. With simplex tableau, do you know what a slack variable is? Do you have any idea what is it?
The slack variable is going to be what you insert after x, y, and z to be able to solve the equation inside the simplex program.
Yeah, okay, but you know what it is physically? No. Okay, so let's talk about what it is physically, all right? A slack variable is the leftovers, all right? So if I have 4 eggs and I use 3 eggs to make my cake, I got 1 egg left over, so that's a slack variable. I got 1. It's my leftovers, okay? So I want you to understand that's what a slack variable is, all right? It's how much you have left over. You're not going to use all your resources that you use to manufacture something. It's what you have left over, okay? But I don't know, for some reason they just don't mention that, and I think it confuses people. All right, so we're going to kind of set up this so you can see how slack variables work. All right, so slack is a term, it's leftover resources. So, you know, she's going to do an example, but like if I'm making a cake with eggs and flour and milk, I'm going to have some leftover eggs and flour and milk. So those, I would have a slack variable for each one of the things that I use to make it. Okay, so for each different type of thing you use, you're going to have a slack variable. Okay, all right, so. So the slack variable is the amount of resource that's not being used. All right, it's the amount of whatever I have left over. That's all it is. All right, so let's read this problem. It says Jerry is buying pizzas for $6 each and sodas for $2 each. He has a budget of $68. So we might have some leftover money, right? Okay, so let's take a look. So if a pizza is $6 and I buy 3 pizzas, that means I'm going to spend $18. Right, for 3 pizzas. If soda's $2 and I buy 12 of them, I'm going to spend 24, right? So if I add those together, that's the total amount of money I spend. So if I add 18 plus 24, I get $42. So I haven't spent all of my money. I have leftovers. That's my slack variable. So if I do 68 minus 42, it's 26. So I got $26 left over. Okay. So, and this is a very simple example because normally it's, you know, whatever you're using to make things with, those are your leftovers. All right, so we'll do a couple more. So if I do 4 pizzas, that's going to cost me $24. If I do 16 times 2, that would be 32 sodas, right? So if I add those together, 24 plus 32 is 56. So the leftover, I had $68, so 68 minus 56, I got $12 left over. Okay, so it's the leftovers. All right, we'll just do a few more and then we'll come some variables. All right, so 5 times 6, the total price for the pizza would be $30. All right, 5 pizzas at $6. I have 16 sodas at $2. 16 times 2 is 32. So if I add them together, I get 62. So I spent a lot more money. Now my leftover is only $6. Right, 68 minus 62. Okay, one more. If I buy 5 pizzas for $6, that's $30. And 18. 2 times 18 is 36. So I spent $36 on soda, so I spent $66, so I got $2 left over, right? So in general, if I spent $6 for a pizza, I bought X pizzas, the price for the pizzas would be 6X. And the price for the sodas, $2 a soda times Y sodas would be 2Y, 2 times Y. So the total I spent would be 6X plus 2Y, right? And that's my slack variable, all right? Whatever I have left over after I spent it, it's 68 minus that, but that's what they call the slack variable. It's whatever I have left over, okay? And to find my leftovers, I'd do 68 minus 6X plus 2Y, right? Just to mention that. Not that you do it. You don't do that in simplex. All right, we okay? So understand the slack variable is the leftovers. Write an expression for the amount of money Jerry will spend on X pizza. So X pizzas and Y drinks, that's this right here, right? We just did it. So X plus 2, 6X plus 2Y. That's how much he's spending. Write an inequality expressing the money spent must stay under budget. So I know that the total price I spend for pizzas must be less than or equal to my budget, which is $68, all right? So that's like your constraints, right, on your simplex tableau. Letting S represent the leftover, write an equation expressing how the money adds up to 68. This is what you're doing with slack variables when you're adding S1, S2, S3. You're adding the leftover so that now it equals exactly whatever your budget is or whatever you had. So what I would do is I would take the money I spent on pizza, I would add the slack variable, whatever's leftover money, and I know that money has to equal $68, all right? So that's why you add those slack variables at the end of your leftovers. Okay. You know, so in those simplex tableau, when you get like S1 equals 2 or something, that tells you you have 2 left over, whatever S1 is. All right, so I want you to understand that's what's left over once you found your maximum profit or whatever it is we're trying to maximize. All right. I really like to set up the simplex tableau. All right. All right, so Judy is buying X pogo. We're going to work another example. Judy's buying X pogo sticks and Y hula hoops for the party. Pogo sticks cost, that's your price, $20 each. Hula hoops cost $10. Her budget for the items is $500. That's my total budget. So the amount she spends cannot exceed $500. So this is kind of the same thing. I'm not going to do all of these because I think we're getting the idea, right? All right, so the total for the pogo sticks, if I buy 20 times 8 is $160, right? The total for the hula hoop would be 10 times 15 is $150. So my total spend there, if I add those together, I get $310. So the leftover would be 500 minus 310, I get 190. All right, that would be my slack variable. All right, so we're going to jump down to the bottom line because I think it's just kind of crazy. So the money for the pogo sticks would just be the value times the number I bought, so it's 20x, right? What's the number for the hula hoops? Here, what should go here?
$10Y.
Y, right? I multiplied 10 by the number of hula hoops, right? So my total spent would be the sum of those, right? So it'd be 20x plus 10y.
Yes, ma'am.
And then we got some left over, which we call the slack variable, right? That's the leftover money. And the budget's 500. All right, so number A, an expression that she will spend on X pogo sticks and hula hoops would be this right here, right? 20x plus 10y. All right, write an inequality expressing the money spent must stay under budget. So I know that the money she spends, which is that, has to be less than or equal to 500. All right. And turning it into an inequality to an equality, I just add that slack variable, right? So I want to do 20x plus 10y plus the leftover, that has to equal 500. So with your constraints, you're adding slack variables to turn them from inequalities into equalities. That's what you're doing. Is that okay? All right, so yeah. Okay, so we're gonna do another slack one. All right, these are kind of more like what you're doing. Man, she goes on and on and on. Okay. Write an inequality expressing the scenario. Ralph is planting X acres of corn and Y acres of wheat. He owns 180 acres, although he won't necessarily plant it all. Okay. So I know an equation. For some reason, she doesn't want you. We're going to write the equation, right? So how would I write an inequality? I mean, I'm going to plant X acres of corn and Y acres of wheat, and I know it has to be less or equal to 180 because I'm not going to just plant all of it, right? Necessarily. So my inequality would be X plus Y is less than or equal to 180, right? Total acres I plant has to be less or equal to 180. Now, to turn it into an equation, which I need to do for simplex, I just simply add a slack variable, right? Do you guys call it x and y or x1 and y1, x1 and x2?
X1, X2.
Okay, so it's the same thing. They're just using x and y, all right? So if you don't like that, think of it as x1 and x2, all right? And then your slack variable will be like S1, the number of leftover acres, all right? So to convert it to an equality, all we do is we add the slack variable and we say it equals 180. So S would be the number of unplanted acreage. All right. If Ralph plants 50 acres of corn and 70 acres of wheat, how much leftover unused acre will he have? So, you know, this is just, if I plant 50 acres of corn and 70 acres of wheat, I've planted 120 acres, right? And I have 180 available, so what's my leftover?
60.
60, right? I do 180 minus 120 is 60. You have 60 left over, right? That won't be planted. Okay. Same thing, 60 acres of corn, 90 acres of wheat. So if he plants a total of, what is it, 150, right? What's his leftover? It's going to be what I have available, right? Minus what I planted, right? Yes?
30.
30 acres left over. That's a slack variable, all right? A resource I'm using would be the acreage. One of the things I like to do with these, a little, because I haven't talked about it, and I'm just dying to do it, is make little tables, all right? So what I can do is I make a table for me. This is what I'm using, and this is what I'm making, okay? So Chloe makes two kinds of fruit baskets. So basically she has two baskets. She has basket A and basket B. That's what I'm making, okay? Now, what am I using? I'm using apples and oranges, and that's it, okay? So I can just fill in my table here. So for basket A, she uses 4 apples and 5 oranges. And for type B, she uses 6 apples and 3 oranges. She has only 8 baskets. That's a resource, right? Okay, so I'm going to make another column here, total. She has 8 baskets available, 52 apples, and 36 oranges. See, I just made a table of that. All right. It's going to help me get my equations, my constraints. All right, so before I answer her question, I hate the fact that we're not just doing this. I'm gonna write the constraints from this and then we'll go back and answer the question. So I know that 4 times the number of apple baskets she makes plus 6 times the number of B baskets she makes has to be less than or equal to 52 because that's the number of apples I have. See, I get that constraint, I just read right across. All right. So in your simplex tab blue, this would be x1 and x2. All right. All right. Now, or is that right? Yes. Now this other one, oranges, I would have 5A plus 3B is less than or equal to 36. Right. And I know that the apples plus the other basket, A plus B, has to be less than or equal to A because I only have 8 baskets. So if you set up a table, I can help you get your constraints. Okay. Okay. So let's read her problem. Her problems are much easier than that. All right. So if Chloe makes 4 type A baskets and 3 type B baskets. So if A is 4 now, how many baskets will she use? Well, I just add them up, right? 4 plus 3, 7, right? So I'll use 7 baskets and I'll have 1 left over, right? All right. Now, if I use, let's talk about apples. So if I use, apples will be this row right here. So let's see, I have 6, no, where am I? Okay, how many apples? 4 type A and 3 type B. All right, so if I have 4A, I'm going to use 4 apples. So it's 4 apples per each one of the 4 baskets, right? I'm just plugging it into here. Plus 6 times B is 3, all right? That would be the number of apples that I use, right? So I use 4 apples for the type A and 3 apples for the, did I just do 6? Did I do something wrong? No, I'm fine. 3 baskets, right? I got it, okay. So I'm gonna add this together. 16 plus 18, I'm gonna use 34 apples, right? But I have 52 available. So I have a slack variable there, so I just do 52 minus 34. I have 18 that are left over. Okay, is that all right? So understand the slack variable is what's left over, all right? All right, how many oranges? So basically the oranges, I use 5 for basket A. I'll just write it this way, and 3 for basket B. And I know that has to be less than or equal to 36. So let's see how many we use. So we're doing 4 of A and 3 of B. So let's figure out what that is. It's 20 plus, it's gonna be 29, right? Which is less than 36. So she's gonna use 29 oranges. And the leftovers would be, I have 36 available, so it's 36 minus 29. So the leftovers would be 7. All right, is that all right? Okay, I think I'm finally setting up the simplex tableau. All right, I'm gonna make this, just to tie this home with you, I'm gonna call this X1 and X2, just so you understand, this is your X1 and X2 in your simplex, all right? So how many baskets will she use? So the baskets, I have 8 of them. So that's X1 plus X2 baskets, right? The number of A's and the number of B's. So X1 plus X2. How many apples will she use? I go to this row. It's 4X1 plus 6X2. And how many oranges? Here's my oranges, 5X1 plus 3X2. See, I'm making a table, you just kind of read them. All right. All right, so that's how many of each you use. Now, they want me to write the inequalities. The inequalities is considering the total. And these are your constraints for your simplex tableau. I'm gonna let this be X1 and this be X2, because that confuses some people. All right. So write an inequality involving the number of baskets she will use and the number available. All right, so I know the number of baskets she's going to use is X1 plus X2, right? The total I have available, go over to this column, is 8, right? So I know that that has to be less than or equal to 8. Okay? So if I rewrite this with slack variables, I'd have X1 plus X2 plus a slack variable. I'll call it S1 equals 8. What does S1 represent? Leftover baskets, right? So it's the baskets I have left over. Good. All right, so the apples. That would be this row, 4X1 plus 6X2. Oh, I already have it, yeah. 4X1 plus 6X2. And I know that that's less than or equal to the total number of apples, which will go to my chart is 52. Okay, so that's less than or equal to 52. So again, using another slack variable, I'm just going to add a different one. Now that's why they call it S1, S2, S3, because they're all different items, okay? So it's 4X1 plus 6X2 plus another slack variable, call it S2 equals 52. Okay, so what's S2 represent?
Leftover apples.
Leftover apples, okay? We got one more to go. And let's see. Number of oranges. The number of oranges would be 5X1 plus 3X2, just looking at my chart. Where'd it go? Where'd it go? Oh, there it is. Oranges, 5X1 plus 3X2. And I know that's less than or equal. The total number of oranges I have, if I look at my chart, is 36. So it's less than or equal to 36. All right. So to write it as an inequality, I'm going to add another slack variable, which represents what? I'm going to call it S3. So the slack variable represents, in this case, what?
Leftover oranges.
Leftover oranges, okay? So for each different resource you use, you have a slack variable. Okay. Sometimes there's 0. You don't have any leftovers. All right. Is that all right? Okay. So now we're going to set up. Oh, gosh. How many are we out of here? 240? Is that right?
Yes.
Okay. If I don't finish this, I'll put a video up there. Oh my gosh, that's just going on and on. Okay. So let's set up a constraint here. Let's set up our constraints. A toy store sells 2 types of toys, A and B. The store owner pays $8 for toy A and $14 for toy B. He estimates that no more than 2,000 toys will be sold every month. He does not plan to invest more than $20,000 in inventory. Okay. Write the constraints for this problem. Okay. Now what I like to do is make a table. So pretty much what I'm making 2 toys. X1 is toy A and X2 is toy B. What I'm making goes on the top. What I'm using to make them goes on the bottom. So what am I using to make them? One is money, right? And there's also a limitation on the number of toys, right? Yeah. Okay, so for toy A, it cost me $8. And for toy B, it cost me $14. I'm gonna make a little total column. All right, and I know that I can't invest more than 20,000, so that's the max right there is 20,000. Okay. Now the number is just straight up X1 plus X2. I don't want to make more than 2,000, so that's the total number, right? Now I can pretty much just write these 2 equations going across the rows, and I've got my constraints. All right. So if I read across the rows, I have 8x1 plus 14x2. Has to be less than or equal to 20,000 bucks. Now there's nothing there, so it's just X1 and X2. So this is X1 plus X2 is less than or equal to 2,000. These are the constraints that I need. All right, so now I've got them, and I can solve my simplex tableau. You're going to add a slack variable to each one of those equations, right, to turn them into. So for your matrix, you would write it this way. Plus S1. That's your leftover money, right? And then you would write X1 plus X2 plus S2, right, equals 2,000. And you could, if I had an objective, I could plug it in a matrix and solve it, okay? The point is when you're doing these constraints, it's often good to lay things out on a table so you get all your equations. All right, because you have to organize it somehow. All right, any questions on this? Are we okay? Okay, so let's talk about reading these matrices. All right, oops. So an identity column, an identity column is a column that has exactly 1, 1, and the rest 0. So like if I look at this, that's an identity column, that's an identity column. Okay, that's where your answers come from. If you don't have an identity column, cross it out. I really wish we had some things above. Let's say this was X1, X2, S1, S2. I'm just going to write this in here in the answer. I can't do it. It's not minimized anyway. So, but okay, never mind. We're not doing that because it's not minimized. All right. So I just want you to understand that these are the identity columns. All right. Those are your non-zero answers when you finish these matrices. All right. All right. So if I look at this one, let's see. A -1 isn't going to work, although it's awful close. All of these are your identity columns, right? Things with zeros and only 1, 1. Okay, that's where your answers come from. So this guy, is that it? No, this guy and this guy. All right, have you had enough of identity columns? Because she goes on forever and ever. Okay. All right, so to figure out your pivot point, is that what they're doing with you guys? You need to find a pivot point? Yes? Okay. So what you're going to do is like, these are your constraints. And this is your objective. All the objectives should be, negative with the 1. To find the one that you want to pivot, the first thing you have to do is find the most negative indicator. That means on the bottom row, find the most negative number. So in this particular case, that's the most negative number. So that's my pivot column. All right. So the most negative is the pivot column. Okay, so the most negative here is there, that's your pivot column. Right, see, I'm just looking at that bottom row. let's see, where's the most negative here? This one? And that one. All right, that's your pivot column. Is that all right? Hopefully we're gonna talk about pivot rows. Once we pick the most negative column, okay, there we go. You're gonna find the most negative indicator, right? And then you're gonna take the entry in the far right and divide it by the entry in the circle column. And what you're gonna do is you're gonna toss out negative fractions, identify the smallest number that remains, okay? So what we're gonna do is we're gonna find the pivot point, all right? So, and we're out of time, so we're just gonna do this one, we're gonna go. All right, so this would be the pivot column because of the -9. So then I'm gonna ignore the bottom row. I'm gonna take 37 and divide it by 7. And I'm gonna take 42 and divide it by 8. Whichever one is smaller, that's the pivot row. All right, so I'm gonna do this real quick on a calculator. This is 5.285. 6, and then 42 divided by 8, 5.25. So the smallest one would be this guy. So I take his row. All right, so in that program, this is row 1 and column 1, 2, 3. I'm going to tell it to pivot in row 1 and column 3. Okay, and that's how I pick my pivot points. You keep pivoting until there's no negatives left in the bottom row. Okay, keep pivoting until there's no negatives. Okay. So you keep pivoting, and then when no negatives stop, you have your answer. Okay. All right. All right, then maybe we'll talk about how to read the answers next time. All right. So you have a test tomorrow. Good luck on your test. Study for it. Go through the review. Do what you need to do. And you have from 12 midnight to 12 midnight. You have from 12 a.m. to 11:59 p.m. Get that test done, okay?
Hey, your review that you put up that we did in class is locked on YouTube. It's a private video for some reason. Is that on purpose?
No, I'll fix that.
Okay.
So,
I was just trying to go back over something.
Class is a private video?
Huh?
The class is coming up as private?
Yeah, the one that you just posted that we did on Tuesday.
I'll
It's
fix
come.
that.
It came up. Yeah, I was just curious. I was trying to review on something and I couldn't get it open.
I'll fix it. It may be I didn't change the settings.
All right. No. Have a good day.
Mrs. Miller? It's Jackson Shorey talking. I'm gonna crank out a bunch of that work this weekend for you.
Okay.
All right.
Good, yeah, do it. All right.
Okay. Have a good day.
Yep. Stop share.
You have a good one.
Right, you too.